So today in research methods, we are going to discuss experimental research methods. So far, we have discussed about historical methods and descriptive methods. In continuing with that, we are going to see what experimental research methods are actually. So we all know experiment is something we are doing. We are doing an experiment with something or with somebody, right? So it is the most familiar type of research design for individuals in the physical sciences and the host of other field. So experiments are usually carried in the field of physical sciences, right? So in physics, chemistry, they will have some laboratory kind of experiments. So so majority of the experimental research comes from those area. So this is mainly because experimental research is a classical scientific experiment similar to those performed in high school science classes. That is true. So in my school days, while doing higher secondary, we used to read subjects like physics, chemistry. So we will have some experiments using in chemistry. We will have some experiment using salts, some sodium chloride, some salt testing. In physics, we will have vernier calipers, pendulum, and some other. Those are experimental only. So with continuing with that, when you are doing something or when you are doing experimenting something in a laboratory setup or in a natural environment, that is the main foundation for experimental research. So you imagine, you consider taking two samples of the same plant, let it be any plant, and exposing one of them to sunlight while the other is kept away from sunlight. So let the plant exposed to sunlight be called as sample A while the later is called as sample B. So you are taking two plants, okay, any two plants. So one you are keeping in the sunlight, one you are keeping in your home, okay. So the plant which is exposed, which is kept in the sunlight, which is kept outside and exposed to sunlight is called sample A, and another thing which is kept in the home is called sample B, okay. If after the duration of the research, so let us say the duration is you are keeping it for 1 month to test the changes, we find out that sample A grows and sample B dies. Okay, even though they both are regularly wetted and given the same treatment. Therefore, we can conclude that sunlight will aid growth in all similar plants. See, so after 1 month, that is a certain period of duration. So what happens is the sample B, which is kept in the home, dies. The plant dies. But though you are wetting in the sense you are watering it daily, you are taking care of it daily. Sample A also you are watering it daily, taking care of it daily. But still sample B, the plant dies because there is no sunlight. So based on this particular experiment, we can conclude that sunlight will aid means help growth in all similar plants. So sunlight is essential for the growth of plants. See, you conduct an experiment on two plants. One is kept in the home, one is kept in the sunlight. You are watering both the plants daily for 30 days. And after 30 days, let's say plant B, which is kept in the home, dies and plant A grows very good. So based on this small experiment, you can conclude that sunlight is essential for, what do you say, for the growth of plants. So this is a basic example of how experiment works, right? So experimental research is a scientific approach to research. I have told you the meaning of the word scientific. Scientific in the sense it should be systematic. It is a step-by-step procedure, right? Scientific in the sense it is a step-by-step procedure where one or more independent variables are manipulated and applied to one or more dependent variables to measure their effect on the latter. So here see, in the experiment, in the plant example, we need at least minimum 2 samples, right? Similarly, in experimental research, we need to have, there should be minimum one independent variable and one dependent variable. So we will see what independent and dependent variables are in the later forthcoming classes. So remember that there should be minimum one independent variable and one dependent variable, and the effect of the independent variables on the dependent variables is usually observed and recorded over some time. Okay, then the effect of, and what is the effect of independent variable on dependent variable is recorded. So when you're recording this after a certain period of time, and you get a result like we did in the plant example, and based on that findings you draw a conclusion regarding the relationship between these two variables. Okay. So the experimental research method is used in physical sciences, social sciences, psychology and education. It is based on the comparison between two or more groups with a straightforward logic, which may however be difficult to execute. That is true. So here you see there should be minimum two groups, then only you can experiment it. With one group it is difficult to experiment, right? So there should be two groups. The two groups will have same set of treatment under different conditions. So remember the plant example. The plant are same only, but one is kept in sunlight, one is kept in home. So there is two things. Two things with same treatment, but the conditions are different, right? So based on the recordings or based on the findings, you are concluding that sunlight is essential. So but since this is a plant, you can take it and you can keep it. But when the group gets larger or something, it may be difficult to execute it. So we will see it, right? So mostly related to laboratory test experimental research designs involve collecting quantitative data. You know what is quantitative, right? I told you. So quantitative is which can be measured and which can be expressed in terms of numbers, and performing statistical analysis on them during research. So therefore making it an example of quantitative research method. Okay. So what are the types of experimental research? They are determined by the way researcher assigns subjects to different conditions and different groups. The types are based on the way how researcher assigns them to different conditions and different groups. So remember the sunlight, remember the plant example. So one is exposed to sunlight, one is kept not exposed to sunlight. So that is the condition. Okay, that is the condition. Condition is exposing to sunlight, not exposing to not sunlight. So based on the conditions and based on the groups, the types of experimental research are classified as pre-experimental, quasi-experimental, true experimental research. So we will see these three types of experimental research in detail. So the first one is pre-experimental research design. So in this type, either a group or various dependent groups are observed for the effect of application of an independent variable, which presumed to cause a change in the simplest form of experimental design and is treated with no control group. Remember that it is treated with no control group. Okay. So either it may be a single group or any dependent variable. It is treated for certain treated in certain conditions to observe the effect on them. Okay, to observe the effect on them which the variables pursue to cause the change. Okay, although it's very practical, it is experimental research is lacking in several areas of true experimental criteria. So the pre-experimental research is further divided into three types. See, here the pre-experimental research is divided into three types. One is one-shot case study, one group pre-test post-test research design, and static group comparison. So we will see what are the three different types are with specific examples so that you can understand it better. So you see here in pre-experimental there is no control group. Either a single group or more than one dependent variable are observed over a certain period of condition or certain period of time and recording the changes. So these are the three types: one shot, one group pre-test, post-test, and static group comparison. So we will see the types of pre-experimental research design with specific example. So you see in one-shot case study research design, in this type only one dependent group, or the name itself saying one shot, right? So only one group, one dependent group or variable is considered. The study is carried out after some treatment which was presumed to cause change, making it as a post-test study. So there is no pre-test here, only post-test. So one shot, only one group. For example, how can I say this? For example, so you are students, right? So you are students. I am taking classes. I'm taking classes for third semester for till December 31st. Okay, so after December 31st, I am conducting an exam. Okay, I am conducting an exam to test the knowledge what you have learned. Okay, the class I am taking is lecture, right? So the class I am giving you is lecture method, and after I am giving the knowledge through lecture method, I am evaluating your performance directly after December 31st. Let us say. So only one shot is there, only one post test. So the lecture method here is the lecture method is the way of imparting knowledge to you, and after the syllabus is over, I am assessing the performance only using examination method. So only post test is studied, no pre-test is studied. Okay, so this kind of study is called as one shot case study design. Okay, so dependent group or variable is considered here. The dependent group is you only, the students. Okay, the method is independent is the lecture, the knowledge delivered through lecture is the independent variable here. Okay, so after giving knowledge for a period of time, after taking classes for a period of time, finally I am going to assess you based on examination. Okay, in the January, let's say. So that kind of post test, that kind of study is called as one shot case study. So now you see one group, see the difference, one group pre-test, post-test, research design. It is exactly the opposite of one shot. Okay, so one group means there is one group, but there are two tests. One is pre-test and one is post-test. The research design combines both the pre-test as well as post-test by carrying out a test on a single group before the treatment is administered and after the treatment is administered. Okay, in a simple example, I have created a portal now. You have seen lislearning.co.in. So when you enter the net examination portal, I might have asked a question for pre-test survey. Okay, pre-test survey means before learning the contents inside the portal, I am assessing your basic knowledge on the subject. That is pre-test. So after you are reading all the contents, 10 units of net syllabus, finally you are again taking the same set of questions. That is the post-test. So before learning, you are taking one test. That is pre-test. So you see, here the treatment is administered. What is the treatment in our case? The units and the subject content. So after learning everything, again you are taking the post test. That means your performance either might have improved or declined, right? So before learning anything, if you are taking the test, obviously your performance will be low. So after learning the concepts and syllabus, if you are taking the same test, your performance will be high. So when you are comparing a single group based on pre-test and post-test, it is called as one group pre-test post-test research design. So one shot is only post-test is there, no pre-test. In one group pre-test post-test, same group only, there is no two groups, only same group. A pre-test is there, and after some treatment, some teaching is done, and then again post-test is done to assess whether they have improved or not. Okay, so static group comparison. What do you mean by static? Means it is stationary. Static in the sense it is stationary. In a static group comparison study, two or more groups. In static means there are two or more groups placed under observation, where only one of the group is subjected to some treatment while the other groups are held statics. So all the groups are post-tested and the observed differences between the groups are assumed to be a result of the treatment. So what do you mean by that? In a static groups, there are two groups. So take the plant example again. So let's take two plants. Okay, two plants of each group. So there is 4 plants. So two plants you are keeping in the sunlight. 2 plants you are not keeping in the sunlight. You are keeping in the home. So the plants which are kept in the sunlight are one group. The plants which are kept in the home are another group. So there is 2 groups here. Okay. So what is the treatment here? Treatment is, it is subjected to sunlight. Okay, it is subject one group is subject subjected to sunlight. One group is not allowed to receive any sunlight. Simple. That is a treatment. So the group on the plant and everything is same. So the treatment is different. Okay, one group is kept in sunlight, one group is not kept in sunlight. So here the treatment changes. So after a period of certain duration, you are testing. What happens? One group, the plant which is kept in the plants which are kept in the home dies. The plant which are kept in the sunlight grows. So that is a post test, right? So based on the observation, you are concluding accordingly. So there is 2 groups. One is subjected to certain treatment, one is not. Okay, here the treatment in our plant example is sunlight. Okay, I hope you understand what these 3 types of pre-experimental research design are. Okay, So next is quasi-experimental research design. So what do you mean by the word quasi? Okay, quasi means partial, half, pseudo. Okay, quasi means partial, not fully, partial. Therefore, quasi-experimental research bearing a resemblance to the true experimental research, but not the same. So it might have certain resemblance, certain similarities to true, but it is not the same. Okay. In quasi-experiments, the participants are not randomly selected. So remember, they are not randomly selected, and they are used in settings where randomization is difficult or impossible. So participants are not randomly selected here, whereas in the true case, participants are randomly selected. So this is common in what you call educational research, where administrators are unwilling to allow random selections of students for experimental samples. Some examples include time series, number of equal and control group design, and the counterbalanced design. So time series, what do you mean by time series is, so over a period of time, how will you perform, or how the conditions will evolve. For example, if you are taking the performance of a cricketer Virat Kohli, for 5 matches, for the first 5 matches he scored 50. So what will be the result of the next 5 matches? You are predicting, that is time series. So based on the past observations, you are predicting, oh, he will definitely score more than 50. It may not be the case, but you are predicting. So those kind of experiments can be done using these times, using this quasi experimental design. Okay. So what do you mean by true experimental design? True experimental design, as I told you, it selects samples randomly. Quasi does not select random based sampling, right? So true experimental design relies on statistical analysis. When statistical analysis comes, means the data can be quantified, that can be expressed in numbers, okay, to approve or disprove a hypothesis. It is the accurate type of experimental design and may be carried out with or without a pretest on at least 2 randomly assigned dependent subjects. It may be carried out with a pretest, or it may not be carried out depending upon the nature of the study on randomly selected dependent subjects. See, here the keyword is random. The samples are selected randomly, okay, not by choice. It is selected arbitrarily, okay. The true experimental research must contain a control group, a variable that can be manipulated by the researcher, and the distribution must be random. So a control group is, you are controlling the group by manipulating the variable, right? So the classification of true experimental design include post-test only control group design, pre-test post-test control group design, Solomon 4 group design. So we will see what these 3 types are. So in the first post-test only control group design, subjects are randomly selected and assigned to 2 groups. Okay. So for example, you are a group of 6 students, right? So I am randomly selected by taking a lot or something. Okay, I am writing all the names of 6 students in a paper. I am randomly picking three papers, and whoever names fall in that category, they are group A and others are group B. So this is the process of random selection. I am not selecting by convenience or choice, just randomly by a toss or by a choice of paper or something. Okay, a lottery method. And when the experimental group is treated, after close observation, both the groups are pre-tested and conclusion is drawn from the difference between these groups. So here the difference is, randomly, samples are randomly selected. Okay, here the difference is samples are randomly selected. The same, I have selected 3 students based on a lottery method, and one group I am teaching it, one group I am teaching the subject, one group I am not teaching the subjects. Okay, so what happens, I am testing them the performance in the exam. So how both the groups perform and compare them. So for 3 students only I am teaching, other 3 students I am not teaching. So finally I want to check the performance of both the group of students. So what happens, based on the results I will come to a conclusion. So whether teaching improves the performance or not. Okay. So this randomly chosen sample falls into true experimental design. Okay. Again, the same we saw in the pre-experimental, but here the difference is the samples are randomly selected. Again, pre-test, post-test control group. The subjects are random. Again, the subjects are randomly assigned to 2 groups. Both are presented, but only the experimental group is treated. And after observation, both the groups are post-tested to measure the degree of measure the degree of change in each group. Okay, so again pre-test, post test. Here there only post test, here pre-test and post test, here pre-test and here pre-test and post-test is there. Okay, again this I am randomly selecting, but only the experimental group is treated. That means whichever group I am taking class, that is only treated. I am selecting 6 students, 3 one is group A, one is group B. So on the experiment is I am teaching only 3 students, group A I am saying. So that group is only treated here. Okay, so after observation, both the groups are post tested to measure the degree of change in each group. Okay, so pre-test I am giving it only for experimental group, but for both the groups again I am doing post test. Okay, so when I do pre-test and post test, that is called as pre-test post test control group design. So what do you mean by Solomon 4 group design? So it is a combination of both the post test only and pre-test post test. That is nothing else. It is a combination of both these top two. Okay, in this case the randomly selected subjects are placed into 4 groups. See here the subjects are placed into 4 groups. So 4 groups, what happens is the first 2 of these groups are tested using this method, first method post test only, and other 2 groups are tested using pre-test post test. Okay, so when you do like this, it falls under Solomon 4 group design. So in this category there should be minimum 4 groups. Okay, so first 2 groups are tested using this method, second 2 groups are tested using pre-test post test method. So when you combine both the methods, this fall into Solomon 4 group design. So this is all about types of experimental research. So now we are going to see some examples in the practical scenario. So these are the different kinds of experimental research. Usually the examples are of experimental research are different depending upon the type of experimental design that is being considered. The most basic example of experimental research is lab experiments, right? Which may differ in nature depending upon the subject of research. Yeah, lab experiment. When you are adding some liquid or some some chlorine or something, some effect into that solution, the automatically recordings will change. So lab experimental are the most common type of experimental research. So we will see certain examples, right? The first example is administering exams after the end of semester. That is what I was talking about, right? In the first example, during the semester, students in a class are lectured on a particular course and an exam is administered at the end of the semester. Remember here, so if we are in the 3rd semester, we are reading the course research methodology and exam is administered at the end of the semester. So after the semester, we are going to conduct an exam. So that is our case. In this case, students are the dependent variables. You are the dependent variables. Remember, when the lectures are the independent variables treated on the subject, not lecturer, not me. Lecture means the class. Okay, that is the independent variables. So now you understood what is dependent and what is independent, right? So you are getting some treatment. And independent variable is, it is stationary. They are giving subject material. Here the independent variable is lecture and dependent variable is your student. You are gaining knowledge from the independent variable. So only one group, that means a group of 6 students, carefully selected subjects are considered in this research, making it a pre-experimental research design example. Yeah, because only we are conducting exam at the end of the semester only, not before. So we also notice that tests are carried out at the end of the semester only, not at the beginning. So that means which category it comes under? One shot case study research. So it comes under one shot. One shot means only one test is administered after the end. Simple. When you are administering it before pre means that will be pre-test post-test. So you are administering at the end only. So it falls into one shot category research. So your example is the best example for pre-experimental design. So you are studying the course for this 3rd semester, and after the 3rd semester you are writing an examination. So based on the knowledge you gained from the lecture, you will reflect the performance on the marks, okay, on the examination, right? So this kind of studies, this is an experiment, right? So this kind of study falls into pre-experiment, that too in the category of one shot case study. So here students are the dependent variable, and the lecture, not the lecturer, not me. Lecture means the class, the subject which is delivered through lecture method. So that lecture is the independent, right? Okay. So next example is employee skill evaluation. So before employing a job seeker means whoever has completed a degree, was searching for a job, that is job seeker. Organization conducts tests that are used to screen out less qualified candidates from the pool of qualified applicants. This way, organizations can determine an employee skill set at the point of employment. See, while you are going for interview, they will conduct some aptitude test, written exam aptitude test. So what they do is they are assessing the skill of the employees. Okay, they are assessing the skill of the employees. Based on this, there will be more than 100 or 200 applicants, right? In order to filter out the good candidates, they will conduct a screening test, like a eligibility test or aptitude test. So based on that, they can determine the employee skill set at the point of employment, right? So they will filter it according to the marks scored on that aptitude test, right? So in the course of employment, organization also carry out employee training to improve employee productivity and generally grow the organization. So after joining the company, after the company has employed you, they will provide training to improve employee productivity. So they will provide training at frequent intervals, depending upon the nature, depending upon the product or something, for the growth of the organization. And further evaluation is carried out at the end of training to test the impact of the training on employee skills and test for improvement. See, so after the training, when you join the company, like a software company like TCS or Wipro or whatever it may be, they will give training. For the first 1 or 2 months, you will be in the training program. You will attend the training program, and in the training, they will teach you about the concepts and the subjects and what are the projects you are going to work on and what are the skills you need, and they will give training. So after the training, they will conduct an exam. Okay, they will conduct an exam whether the training was useful or not. Like we students write an exam, right? So based on that, they will check the knowledge and the skill level of employee, right? So here you see the subject or the dependent variable is the employee, and the treatment conducted, and while the treatment is the training conducted. Similar. Okay, that is an independent variable. So this is a pre-test, post-test control group experiment research example. Okay, can you understand this? So next is evaluation of teaching method. You are evaluating a teaching method, right? So let us consider an academic institution that wants to evaluate methods of 2 teachers to determine which method is best. Okay, so the college wants to determine 2 different methods. One might be lecture or one might be whatever it may be. 2 different methods, and they were of 2 teachers, and they want to find out which method is best, right? So imagine a case whereby students assigned to each teacher is carefully selected, probably due to personal request by parents or due to stubbornness and smartness. See, here the students are assigned to a particular teacher. There are 2 teachers here, but students are carefully selected based on the request by parents. The parents says, no, this teacher is good, so I want my students to study under this teacher, or based on the skill level of the students, or stubbornness or smartness. So there is no equivalent group. There is no probability. There is no there is no randomness here. There is no equivalent group design example because the samples are not equal. Okay, unless you chose them randomly, the samples are not equal. By evaluating the effectiveness of each teacher's training method this way, we may conclude that after a post-test has been carried out. So after a period of time, so 3 students, you are selecting 3 students. So here we are having 6 students, right? So 3 students are learning under me, and 3 students are learning under one more teacher, right? But here the samples are not randomly selected. The samples are selected based on certain parameters, either by influence of parents or influence of organization or influence of the skill of the students, right? So it is not random. So that means it will never become a true experimental design. So after a period of time, after the teaching is implemented over a period of time, then they will conduct the evaluation to assess which teaching method is best and which teacher has taught which teacher has imparted more knowledge to the students. However, you see, however, this may be influenced by factors like natural sweetness of a student. For example, a very smart student will grab more easily than his or her peers, irrespective of the method of teaching. That is true, right? If a student has good knowledge and good skills, he will easily observe. Even though the teacher is not teaching, he will easily observe the concepts. Whereas a slow learner might find it difficult to observe, right? So there are some factors you need to consider. So there are factors influenced. So this kind of study is an experiment, but it is not true experiment because the samples are not random. Remember that. So these are the different kinds of examples, right? So you think of examples in our field, how we can conduct experimental research in library and information science, right? Think of that. So next is characteristics. What are the characteristics of experimental research? So one is variables and the setting and the multivariable phenomena, right? Experimental research contains dependent and independent and extraneous variable. So you know dependent, independent variable. So we saw example. What do you mean by extraneous variable? Extraneous is they are lurking variable. They are involved but they don't directly affect. That is extraneous. They are involved. They are there but they don't directly affect. These dependent variables are the variables being treated. In your case, students are the dependent variable and sometimes are called the subject of the research. Independent variables are the experimental treatment being exerted on the dependent variable, right? What is the experimental treatment here? Lecture, the class. That is the treatment or the training. Extraneous variable are the factors affecting the experiment that may also contribute the change. For example, the good example is I am teaching. I am giving lecture on Google Classroom, right? I am giving lecture on Google Classroom. Here, the lecture is independent variable. Students, you are the dependent variable. What is the extraneous variable is the internet connection. The internet connection or the power cut. So that are there, but sometimes they don't directly affect. But on certain occasions they will affect. So these kind of lurking variables are called as extraneous variable. If internet goes, what happens? Our meet and our class will be gone, right? So see, they are other factors which affecting the experiment. So these kind of variables are called extraneous variables. So setting is the actual environment, right, where the experiment is carried out. Many experiments are carried out in lab where control can be exerted and the extraneous variables they are thereby eliminating them. So other experiments are carried out in a less controllable settings. The choice of settings used in research depends upon the nature of the experiment being carried out. So most of the experiment, the where you are carrying out the experiment is the setting, okay. So the choice here in the plant example, the choice of experiment is home and outside, right, sunlight. So in certain cases in physics you have to carry out in lab, okay. So in order to eliminate the extraneous. So in the plant example, you remember that you are carrying out an experiment on what do you call a plant example. One is sunlight and one is kept in home, right? So you are thinking that sunlight will come. What happens? Suddenly the next day a heavy rain and flood comes. You don't know. We cannot predict the weather, right? Suddenly heavy rain and flood comes. So automatically the plant gets died, right? So you cannot say water killed the plant, right? So these kind of variables which are there, those are called extraneous variables, right? Other words, lurking variables. They will be there. Sometimes they will affect, okay? Sometimes they might be affect, but we cannot predict. We are testing this experiment on summer only, but still it rains. There is a heavy rain on the next day. What happens? So unfortunately, the plant will washed out, right? So those kind of these rain and everything, this internet connection comes under extraneous variable. What do you mean by multivariable? Multivariable means there will be more than one variable, right? As I already told you in the definition of experimental research, there should be more than one independent and one dependent variable, right? So experimental research may include multiple independent variables, right? There may be two independent variables like time, skills, test scores, etc. Okay, there might be two independent variables. So for example, your age is an independent variable, your gender is an independent variable, right? So these are the various independent variables. When we come to this, what you call the statistical and other methods of research, we will see what variables are actually in detail. So why to use this experimental research design? So it can be majorly used, as I told, majorly used in physical sciences, social sciences and education, as well as in psychology. So some of the uses of this design are highlighted below in different disciplines. In medicine, experimental research is used to provide proper treatment for diseases. That is true actually. In most cases, rather than directly using a patient and the research subjects, researchers takes a sample of bacteria from the body and they are treated with the developed antibacterial changes, right? So they will instead of directly testing the patients, they will take the bacteria from the patient's body and they will test with the antibacterial substance like medicine, right? So whether the bacteria is killed or not. If it is killed means they can apply that medicine, they can take that antibacterial medicine. Okay, instead of directly testing on the human, they will test only the bacteria part which is taken from the human skin or something. The changes observed during this period are recorded. How the bacteria, how long it takes for the antibacterial to kill the bacteria and evaluate to determine the effectiveness, right? It will take 2 days or 3 days something. So based on that, they are giving medicine. So here, this fever will go in 3 days. This fever will go in 1 week, like that, right? So this process can be carried out using different experimental research methods. So in medicine, the research works like this, experimental works like this. When you come to education, we saw lots of example in education, right? Aside from science subject like physics, chemistry, which involves teaching students how to perform experimental research, it can also be used to improve the standards of an academic institution. Yeah, these experimental research design can be used to improve the standards. This include testing students' knowledge on different topics, coming up with better teaching methods, and implementation of other programs that will aid students' learning. See that students' knowledge after teaching how your knowledge is. So we saw certain example and coming out with best teaching methods. We saw an example, right? And implementation of programs that will aid students' learning. So whether this program will help into student learning or not, you can experiment this. So these kind of tests, these kind of researches which are carried out in academic institution fall into the education scenario of experimental research design. So human behavior in psychology also they are using experimental research to a larger scale. So social scientists are the ones who mostly use experimental research to test human behavior. So for example, consider two people randomly chosen. Randomly chosen means you should remember it is true experiment. Whenever the word random comes, it is true. Okay, true experimental research design. So two people are randomly chosen to be the subject of social interaction research where one person is placed in a room without human interaction for 1 year. Okay, 1 year, that means they are taking two people and for one person they are allowed to talk with other people to assess the social interaction, and the another person what they did is they have kept him in a room or a house for 1 year without meeting anybody. So he is not meeting any person or even in the outside world, right? So this way they can experiment the social behavior, right? The other person placed in a room with few other people enjoying human interaction. There will be a difference in behavior at the end of the experimental. Okay. See, so one person is placed in a room with friends. So another person is placed in a room without anybody. So they obviously one person who is placed with other people will enjoy human interaction. So based on that, they will assessing the difference, and there will be a difference based on 1 year. After 1 year, they will assess their behavioral patterns, right? So how he comes out after 1 year? Both people comes out after 1 year. So UI UX is user interface and user design. They are these experimental research are used in these kind of scenarios also. During a product development phase, one aim of the product team is to create a great user experience with the product. Therefore, before launching the final product, design potential are bought in to interact with the product. So for example, when finding it difficult to choose how to position a button on feature of app interface, a random sample of product testers are allowed to test two samples on how the button positioning influence a user interaction is recorded, right? So you see in WhatsApp and other Telegram and whatever it may be, there will be a beta version. That beta version is nothing but there is a testing version before the final product. If the users are the beta version is available for the public, you can what do you say? You can test and you can give your opinion. No, this feature is not good. It is difficult to use. But this is very good. You can implement it. If the beta version is successful, that means they will launch the final product. If the beta version is not successful, they will collect the feedback and they will modify it accordingly. So that is why user interface and user design are very important. So experimental research plays a vital role in product selection and product finalization. Okay. So these are the applications of experimental research in various disciplines. So there are some certain disadvantages also. Let's see what are they. It is highly prone to human error due to its dependency on variable control, which may not be properly implemented. These errors could eliminate the validity of the experiment and the research being conducted. That is true, right? You are saying that the plant example, one is kept in sunlight, one is kept in home, but the condition is every time you have to water it daily, both the set of plants, whether it is kept in sunlight or home. You forgot to water. Okay, if you forgot to water, both the plants will die, even though if it gets sunlight or not. So it is prone to human error. Okay. Exerting control of external variables may create unrealistic situation. Eliminating real-life variable will result in inaccurate conclusions. This may also result in researchers controlling the variables to suit his or her personal preferences. See, I told you what is external. What do you mean by external variable, right? Extraneous variable. For example, same plant example, in the same plant example, in order to in order to eliminate extraneous variable, that is the rain or something, you are keeping in a place only certain part of sunlight comes. So, but if rain comes, it will not affect. That means you are eliminating. You are not giving full condition, full sunlight to the plant, right? You are just eliminating the extraneous variable to suit your needs. So that is a biased kind of research. If you are keeping in sunlight, means you have to keep it in sunlight, irrespective of considering the extraneous variable, right? Rain comes, we cannot do anything about it. It doesn't mean you have to take precaution for the rain. You need not to take, in certain condition, you need not to take precaution for extraneous variables. You have to observe the phenomena in the natural setting to get correct and accurate conclusions. So if you are keeping the plant only with one portion of sunlight, and you want to avoid rain, if rain comes everything will be destroyed, means you are avoiding, you only one part of plant is getting sunlight. Okay, you are keeping in such a way in order to avoid rain. So rain is extraneous variable, we don't know when it will come, right? So but if you want to take care of that, that sense, means that is biased, right? You are not observing the plant in a natural setting, you are not keeping it in full sunlight. You are protecting the plant from rain actually, instead of keeping it sunlight. So that will be a disadvantage, right? You cannot get accurate results and you cannot determine the validity. So it is a time consuming process, that is true. Based on, see, for a student semester examination, I have to wait for a whole semester to find out whether you have studied or not. So it is a time consuming process. So much time is spent on testing. We are testing dependent variables and waiting for the effect of the manipulation of dependent variables. It is expensive, that is true. It is risky and may have ethical complications that cannot be incurred. This is common in medical research where failed trials may lead to patient death or deteriorating health condition. That is true. If you are ethical factors are there actually in medical. If you are doing something on animals or even on humans, if you are testing a vaccine, means you have to get proper permissions from that human, right? Without permission, if you are testing something, means it is a new vaccine. If there is side effect, means he will die or he will have some other diseases. So you have to get the ethical. It is risky. It is very risky. So you have to get no objection from the ethical board and from the test participant itself and everything. So all these protocols need to be followed in experimental research, right? Are not descriptive. They are not descriptive. They are not just describing the phenomena. They are actually saying what happens after the variable is monitored at certain conditions. Descriptive research is just describing the phenomena. What, how, right? It is not, descriptive research will not answer why question, but experimental research answers the why question. So why plant grows? why plant grows, why plant kept in why plant kept in the home died, why plant kept in the outside grows. So it's answer the why question. So that means because of sunlight it grows, because lack of sunlight it died. So descriptive research is just describing the phenomena, what, how, okay, what, how and where, the characteristics of a phenomena or an institution or an individual. We saw that, right? The experimental research is different. It is not descriptive. Response bias can also be supplied by the subject of the conversation. Human responses in experimental research can be difficult to measure. That is true. So there will be bias. Response bias, we saw that in descriptive also. Response bias means, for example, if you are giving a questionnaire means, and sometimes they will not give correct answers. That is response bias. Okay. Human responses is difficult. Sometimes it is difficult. Human responses and experimental research is difficult. That is true. Okay. So these are some of the disadvantages. So what are the data collection methods? So there are different data collection methods. We know the main thing is observation, right? So in the plant example, I'm saying the same example because you will understand it. So the plant example, you are observing it daily for the 30 days. So how the plant grows, or how the plant grows kept in sunlight grows, or how the plant kept in home, what happens to it, you are observing. So this type of study is carried out over a long period. You are observing it for a long period. It measures and observes the variables of interest without changing the conditions. So one is kept in home, one is kept outside. So you are not changing anything. So the conditions for both is same on respect to the group, right? You are observing over a period of time. So it takes long time. So when researchers researching the effect of social interaction on human behavior, the subjects who are placed in two different environments are observed throughout the research. No matter what kind of observed behavior that is exhibited by the subject during this period, the condition will not be changed. It will be very risky in medical cases because it may lead to death or worse medical condition. You say, one example we saw in human behavior. One person is kept in a room with a group of people. He has time to interact for 1 year. So another person is kept alone only for 1 year. So over a period of time, he will get angry, frustrated, he will hit the wall because he has nothing to do. But still, you cannot change it. You cannot change it. You will just observe. You will just observe his behavior. That is the primary objective of research, right? So in medical, as I said earlier, it will be risky. If the vaccine composition of the medicine is not the proper means, it may lead to death also. Because this is trial and error only. Only after testing only you will know whether this vaccine is successful or not, right? So sometimes it may lead to disasters. So that is observation method. Simulation. Simulation is you are creating an artificial environment like a real life environment. For example, how can I say this? For example, if you have attended driving school, car driving classes, most of them have simulated car, right? Simulated environment. That means you will not be driving in the real car, but you will be driving a simulated which will look like a real car, like a video game with all the traffic conditions and everything. You will be in a room and you will be sitting in the simulator. You will be driving and the steering and everything will be there, gear and everything will be there, but you are not in the road actually, but you are in the simulator. You will be driving the car. Okay, but there will be accidents, there will be people coming in. You will see your car through the monitor. That means the car which is not actually driven on the road, but you are assuming that you are driving the road through the simulator. Simulator means creating artificial environment like to replicate real life environment. Simple. Okay, this method is commonly used in engineering and operation research for learning purposes and sometimes used as a tool to estimate the possible outcomes of real research. See, if the car instructor puts you in the car without teaching the principles, there will be a lot of accidents, right? So simulator will help you. If you do accident in a simulator, no problem, because it is like it is not real. It is a simulator, but the gear and the steering and the brakes and the accelerator, everything are same. Okay, but you are driving in a simulator, not in the real road. So once you practice well in the simulator, it will be same in the real life, right? So that is why these simulations are very much useful. Okay, if I give directly in the road, you go and kill somebody, means what will happen, right? But here in the simulator, if you do an accident, that is okay, you can learn from that. But sometimes real life experiments cannot be taken back, right? So if you while you are learning it, instead of holding the brake in the road, if you are giving accelerator, means that it will go out of control, and you will end up crashing someone, or you will end up crashing yourself in some wall or something. But in simulator, if you do the wrong thing, nothing will happen. That means you are learning. So simulation experiment is very essential in certain cases. That too, when the actual situation is expensive, or actual situation may lead to some disaster. Okay. So what do you mean by surveys? We know what is a survey, right? It is using, it is getting a comprehensive data about a particular category or particular phenomena or something. It may be used interviews, methods. It may be used interviews, observations, schedules, questionnaires, or whatever it may be. A survey is a tool used to gather relevant data about the characteristics of a population. So census data, whatever it may be. And one of the most common data collection methods, that is true, it is common. It consists of a group of questions prepared by the researcher to be answered by the research subject. That questions may be sent through questionnaire, or mailed questionnaire, or even interview. I am preparing a set of questions, and when I meet you, I will ask it. That is interview. And surveys can be shared with respondents both physically and electronically. When data collected through surveys, this kind of data depends on the respondents or the researcher, or limited control over it. Okay, that means whatever data you give, the respondents give, I have to accept it, and I cannot control what you give. Right? That is up to your discretion. And researchers have limited control. That means researchers cannot control wholly, fully. So coming to the end part of this experimental research, they are often considered to be the standard. They are the standards in research designs. This is partly due to the common misconception that research is equivalent to scientific experiment. A component of experimental research design is research is not equal to scientific experiment. It is a systematic procedure to draw answer to a particular problem. That is a misconception. Research is not a scientific experiment. It is a systematic investigation to solve a particular problem, to find a solution to a particular problem. Experimental research is a part of research. Simple. It is a type of research. So the misconception, you must understand the difference. The misconception is misunderstood. In this research design, one or more dependent variables is assigned to randomly assigned, means true experimental remain to different treatments, independent variables manipulated by the researcher, and the results are observed to conclude, as we saw earlier. One of the uniqueness of this research is it is in ability to control the effect of extraneous variable. You can control on certain conditions the effect of extraneous variable. It is suitable for research whose goal is to examine cause-effect relationship. What is the cause and what is the effect of this? Okay. If the cause is, if I keep the plant on sunlight, what will be the effect? If I keep the plant on if I keep the plant in home, what will be the effect? So this is a cause effect relationship. It can be conducted in laboratory or field settings depending upon the aim of the research that is being carried out, right? So this is the summary of experimental research method in a nutshell. So this is the source of references which is used to prepare this particular PPT presentation. So thank you.